Hi guys, good morning. Yes, can you hear me? Hello.
Sir, good morning, sir.
Yeah.
Yes.
So thank
Morning,
you.
sir.
Yeah, thank you. So we'll start session. So yesterday discussed about interpreter and compiler. Look at difference between interpreter and compiler. Yes. So today let us start. What are the features of Java? Java features. Java features. Yes, 1 second. Yes, Java. So first version of Java released with below features, right? So these points previous class we discussed. Okay. Yes, all this. Okay, so these things, all the features discussed previously. Okay. Yes. Yes, today, yes, Java features. Let us start this. Independent of platform. So first one, independent of platform. So what is independent of platform? Okay. So first one, 1 second. Yes, independent platform. Java is an independent platform. Let us see. Yes, how Java is independent platform. So first of all, what is independent platform? Okay. So first of all, what is independent platform? How Java made us independent platform? Let us see this. Okay. Platform means OS. Platform means yes, it's a operating system. Yes, previous class about OS discussed. OS, it's a platform. OS is a platform where we can run all programs. Okay. So here platform means OS. So Java is the independent of platform. That means Java is the independent of OS. Yes, how it is here. Let us see. Let us see about this. Okay. Yes, before going to this, let us see about exe file. First of all, about exe file. Yes, about exe file. So question is here, what is exe file? Question is, what is exe file? What is exe file? So how to answer this? So answer for this. What is exe file? So yesterday something discussed about exe file. So how to build exe file? Okay. The steps in C language we discussed here. What is exe file? What is exe file? Let us see what exe file here. See here exe file as per yesterday's one here. See at the time of creation of exe file, C program binary codes, next C library codes, and OS library linking and generating exe file. Okay. So what is exactly exe file? Exe, yes, it's a binary format file. It's a binary code file. Yes, it's a binary code file. Yes, it is a system understandable. Yes, it is a system understandable. System understandable. Yes, it is a system understandable. It is system understandable code here. It is a system understandable code here. Okay. Yes, it's a binary code file. Yes, it's a system understandable code. Okay. Yes, it's a binary code file. Yes, it's a system understandable code. Okay, fine. Okay. Yes, ex system can understand exe file directly. It will execute directly here. Okay, exe file can be executed by system directly here. Okay. Yes, system is processor. Okay, system. Yes, system. Yes, can execute. Can execute. Can execute. Yes, exe file directly here. Can execute exe file directly here. Okay, already converted file. Okay. Yes, it is a prepared file. Exe file. Yes, it is a prepared. Prepared is a prepared file for yes specific operating system, specific OS, specific OS. Okay, exe file. It's a prepared file, specific OS. Okay, so exe file contains what? So exactly what is exe file? Exe file contains what? So exe file contains your program binary code. Next, application software library. That means C software library. Okay, next OS library. Okay, yes, exe file. Yes, exe file. Yes, exe file consists of. Yes, exe file. Yes, consists of. Yes, first one. First one. Program binary codes. Yes, binaries of program. Binaries of program. So binaries of program. Yes, next second one. Second one here. Yes, binaries. Binaries of. Yes, software library. Binaries of yes software binaries of software library here software library binaries of software library here library and OS library here binaries of yes OS library here OS library binaries here. Okay, next third one. Yes, OS library OS library OS library. Okay, right. Yes, suppose for example here for example for example cexe file prepared on Windows OS. For example, here, for example, yes, C program, yes, C program, yes, exe file prepared, yes, prepared on Windows OS, prepared on Windows OS. Then it contains, then yes, C program, exe file, C program exe prepared on Windows OS. Then it contains, it contains then it contains yes C program codes. Okay, so binary code of C program here. Binary code of C program. So binary code of C program. Okay, so it contains binary code of C program. Okay, yes, binary code of C program. So the C program binary codes. So binary yes codes of C program. Okay, yes, next plus yes C library binaries. Okay, one second. Simple understanding. C program binary codes. Yes, your C program binary codes plus. Okay. Yes. C library binaries. C library binaries. C library binaries. C library binaries plus. So C program binary codes plus C library binaries and OS library binaries. OS library binaries here. Okay, now here C program exe file prepared Windows OS here. Then yes, it contains C program binary code, C library binaries here. Next Windows OS library here. Okay, yes, Windows OS library binaries here. Binaries. Next, Windows OS library binaries here. That's it here. So this is complete C program exe file. Okay, yes, C program exe file prepared Windows OS here. Yes, C program exe file prepared on Windows OS, Windows OS. Then it contains C program binary codes, C library binaries, Windows OS library binaries here. So this is C program exe file. Suppose same thing if it is C++. Let us take C++ here. C++ exe file prepared on Windows OS. Then it contains C++ program codes. Next C++ library binaries, Windows OS library binaries here. Okay, next, suppose one more example. So this first example. Okay, next example. Yes, next one more example here. One more example. Yes, C program exe file exe prepared on Linux base. Then it contains C program binary codes, C library binaries. Yes, Linux based library. That is Linux based library. Okay, right? That means exe file is a prepared file for the specific OS. Okay, exe file. So exe file. Yes, exe file is a prepared file. Is readily available. Prepared file. Okay, so exe file is a prepared file. Prepared file for specific OS. Okay. Yes, exe file is a prepared file. Exe file is a prepared file for specific OS. Exe file is a prepared file for specific operating system. Okay, here question is here. Some question for you guys. Some question for you guys. You guys some question. Okay, some question. Suppose C program exe file. C program exe file prepared. Yes, C program exe file prepared on Linux base. Can I run on Windows base? That's a question here. C program exe. Yes, C program exe file. C program exe file. C program exe file prepared on Linux OS. Can I run on Windows OS? That is the question.
No, sir.
Yes, anyone can answer this? C program exe file prepared on Linux OS. Can I run on Windows OS? No.
No,
No.
sir.
No. 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 Yes. No. Yes. Exe file is a OS. Reason exe file is a OS dependent. OS dependent. Exe file is OS dependent here. Exe file is a OS dependent. No question is here. Why exe file is OS dependent? Why exe file is OS dependent? Dependent. The next question. Why exe file? Yes, all these Hindu questions. So what is exactly exe file? Okay. Yes. See here. What is exe file means? How to answer that? What is exe file? What is exe file means? Simple answer here. So exe file is a binary code. It's a system understandable format here. Okay. The exe file contains program binary code. That exe file contains binaries of a program here. Okay. Next, binaries of software library and binaries of OS library. Okay. That exe file linked with OS library. Exe file linked with OS library at the time of creation of exe file itself. At the time of creation of exe file itself, that all the OS libraries linked with exe file. Okay, so it's a prepared file for the specific operating system. Exe file is a prepared file for specific operating system. Okay, suppose if it is prepared on Linux OS here, the Linux library links with exe file. Suppose if it is prepared on Windows OS, then Windows library links with exe file. So exe file is a OS dependent. Yes, what is the reason? Why exe file is OS dependent here? Yes, exe file is a OS dependent reason. It's a prepared file for specific operating system. Okay. Yes, it contains. Yes, answer is here. It contains OS library. Simple answer. Okay, simple answer. It contains OS library. OS library. Simple answer here. Why exe file? So why exe file is OS dependent? Question is here. Why exe file is OS dependent? Why exe file is dependent? So why exe file is OS dependent? For this answer, it contains OS library. OS library. Yes, it's a prepared file. It's a prepared file for specific operating system, specific OS. Okay. Now let us see about exe file. Yes, how it's working. Yes, let us take some platform. So first, yes, suppose for example here exe file. For example, now exe file prepared on Windows OS, on Windows OS. Then it contains Windows library. Then it contains Windows library. Win library here. Windows library. Okay, right? That's it here. Suppose for example, test.exe. Yes, for example, test.exe file. Yes, prepared on Windows OS. Then it contains Windows library here. Okay. Now same test.exe file. Let us place some different operations here. Okay, test.exe file. Test.exe file placed on different operations. See, so first one, let us start with Windows OS here. Let us take different platforms here. Yes, your system. This is system, your computer. Suppose here hardware. Yes, hardware. Here is hardware. Yes. See, on top of hardware, there's a OS. For example, Windows OS with the Win library. Okay, so hardware, on top of hardware, this is Windows OS with Win library, right? Win library. Okay, right? Now, this is test.exe file. Yes, that C program exe file. Placing on this. Okay, C program test.exe file. So test.exe file. Okay, test.exe file placing on Windows OS. Okay, this test.exe file. So test.exe file placing on Windows OS. Okay, see, for example, test.exe file prepared on Windows OS, then it contains Windows library. Okay, fine. Now test.exe file placing on Windows OS. test.exe file placed on Windows space. When you placed on Windows space here, now test.exe file, it will try to call, yes, it will try to call Win library. Yes, it will try to invoke Windows library here. See, tested.exe file linked with Windows library. Tested.exe file linked with Windows library. So using that library communicates with the hardware. See, previous class we discussed any program has to link with OS library to communicate with hardware components. Any program has to link with OS library to communicate with the hardware components. Any program, maybe C program, maybe Java program, maybe C++, you take any program. All the programs have to link with OS library to communicate with hardware components. Yes, in case of C language exe file, maybe C language exe file, or C++ exe file, or .NET exe file. This all these exe files linked with OS library at the time of creation of exe file. It's a static linker. It's a static linker. Simply these are static link here. Okay. Yes, at the time of creation of exe file, at the time of building exe file, at the time of building exe file itself, all the OS libraries linked with the yes exe file is a static linker. It's a static linker. At the time of creation of exe file itself, not at runtime. Suppose library linking at runtime, that is called dynamic linking. If it is library linking at runtime, it's a dynamic linking. But in case of C language, what happens here? Yes, all the libraries at the time of generating exe file itself, at the time of generating exe file, at the time of generating exe file itself, linking. So it's a static linking. In C language, it's a static linking. It's a static linking. At the time of generating exe file itself, all the OS libraries links to exe file is a static linking. Okay. Suppose, for example, here test.exe will prepare Windows OS here, then it contains Windows library. Okay. Now test.exe will place on Windows OS. Try to run it. When you try to run it here, yes, it makes a call to, yes, just a call to Windows library. It makes a call to Windows library. Just you will try to call Windows library. Windows library. It will try to call Windows library. Windows library. Trying to call Windows library. Yes, it's available. Same environment, same that OS library, Windows OS. Yes, Win library available here. So call to Windows library. Yes, using Windows library, then communicate with the hardware components. Fine. So this is working environment is like this. Yes, how it's yes executing that, how that exe file is working is here like this. Okay, that exe file. Yes, once you execute that exe file, it will try to invoke Windows library. Yes, it's available. On Windows environment, Windows library is available here. Using that, it will communicate with hardware components. Fine. Now let us take another platform. Another platform. Yes, another platform. So Windows platform. Next, Linux platform. Let us take Linux platform. Linux platform. Linux platform. Okay, Linux platform. Now okay, Linux base. Linux base. Linux base. Linux library here. Linux library. Okay, Linux platform. Okay, now test.exe file. Same test.exe file. Same test.exe file. Place on Linux library. Now try to run it here. Try to run it here. When you try to run it here, it will try to call Windows library, but here Linux library is available. That library is not matching. Exe file is linked with Windows library. So when you try to run it here, the test.exe file, it will try to call Windows library. It will try to call Windows library, okay, but not available. That environment changed, that platform changed, OS changed, right? Simply it fails. Okay, try to call Windows library here, but fails. So here it fails here, simply just fails. So here fails. That's it. Okay. Now let us take one more platform. Suppose Unix platform. Unix base. Let us take Unix base. Unix base here. So this is with Unix library. Unix base with Unix library. Okay, right? Now same test.exe file. Same test.exe file. Let us place on Unix base. After placing Unix base, try to run it here. Now same it will try to call, yes, try to call Windows library, but here Unix library is available. It's not matching. Library is not matched, simply fails here. That's it. Fails. So you can, if it is trying to call Windows library, on Windows base, same library is available. Library is available, so it can communicate with the hardware here. But here library is not matching. Here library is not matching. Since not matching, simply fails here. That's the reason exe file is OS dependent. Okay. So why exe file is OS dependent? Reason here, it contains OS library. Simple answer. Exe file contains OS library. Since exe file contains OS library, it's a OS dependent here. That's the reason here. Okay. So your question is why exe file is OS dependent? Reason, it contains OS library. That's it here. It contains OS library. Okay, 1 second. Yes. It contains OS library. Okay, now let us go to Java here. Java. Now let us come to Java. Okay. Yes. How Java made us independent of platform? Now question is how Java made us independent of platform? How Java is independent of platform? Yes, independent. Yes, independent. Independent of platform. Independent of platform. Independent of platform. Yes. How Java is independent of platform? Let us see. Yes. So independent of platform is independent of OS. Yes, it will run on any OS here. Okay. How? Yes, how Java made us independent of platform. So first of all, now what is dot class files? First question is what is dot class file? In Java it's a dot class. In Java everything is dot class. Okay. See in Java everything. Yes, everything is a dot class file. Everything Java. Yes, everything is a dot class. Is a dot class file. Dot class file. Okay. So what is dot class? Now question is what is dot class file? Yes, how to answer this? For this answer, what is dot class file? Yes, dot class. Yes, dot class. Yes, dot class file is a bytecode file. Dot class file. First point, simple answer is here. Dot class file is a bytecode file. It's a bytecode file. Dot class file is a bytecode file. Yes, it is not an exe file. It is not an exe file. Yes, it's not exe. Exe file is different. Dot class is different here. Dot class file is not a exe file. Okay. So dot class file is a bytecode file. It's a bytecode file. Dot class file is a bytecode file. Dot class file is a bytecode file. It's not a exe file. Yes, it is not a. Yes, it's not an exe here. Dot class is different. Dot exe is different here. Okay. Dot class file is a bytecode file. It's not an exe file. It is not an exe file. Okay. Yes, exactly what is dot class? Dot class file contains what here? Okay, see here dot class file. Dot class file contains dot class file contains dot class file contains first one bytecode for Java program. Bytecode for our Java program. Suppose some Java program, suppose Hello World program developed. Java some Hello World program developed. Bytecode for that program. And Java library that's it here. Okay, that's it. Okay, yes, dot class file contains bytecode for Java program and Java library. Only Java program, Java library. So Java library also developed in Java here. Okay, Java library also developed in Java. That means it's pure Java program. Okay, yes, it is a pure Java program. It's a pure Java program. It's a pure Java program. Simply, it's pure Java program. Okay. Yes, it does not contain any OS library. Yes, it does not contain. It does not contain any OS library. It does not contain any OS library here. OS library. It does not contain any OS library here. Okay. See, dot class file contains bytecode for Java program and Java library. So bytecode of your Java program, Java library, purely Java program. So it's a pure Java program. It's a pure Java program. It does not contain any OS library. Okay, fancy about dot class file. Now let us see running dot class. Yes, how dot class file is working here. Let us see how dot class is working. Okay, let us see. Suppose tested dot class file. For example, let us take tested dot class file. Tested dot class file. Okay, tested dot class file. Okay, suppose for example, tested dot class file prepared on Windows OS. It contains only Java program, no Windows library. Okay, tested dot class file. For example, here, see, for example, tested dot class file prepared on Windows OS, or any Windows OS or any ways here, anyways. Yes, it contains only Java program, Java library. It contains only, it contains only Java program, Java program and Java library. It contains only Java program and Java library here. It contains Java program and Java library. That's it here. Okay. Yes. So here, yes, dot class will prepare an interface or any operating system. It contains only yes bytecode for Java program and Java library. That's it here. Java library. Yes, it does not contain any voice library. No voice library here. No voice library. No voice library, right? Yes, no voice. It does not contain any voice library here. No voice library. Purely Java codes. Purely Java codes. Okay. Now, how this Java program is running? Now let us see here. Now test.class. Test.class file. Placing on Windows OS. How this will be running here? See, when come to Java here, yes, tested.class. It's a tested.class. It's a tested.class file. Tested.class file. Okay, tested.class file. Okay, tested.class file placing on Windows OS. Between tested.class file, Windows OS, something is there. So what is that? We'll discuss next. Wait 1 second. Now tested.class file placed on Windows OS. So tested.class file placed on Windows OS, right? After placing on Windows OS here, this tested.class file has to link with Windows library. The tested.class file, this tested.class file, yes, has to link with Windows library. Okay, see, every program has to link with Windows library to communicate with hardware components. Suppose if it is exe file, at the time of generation of exe file itself linking to Windows library, it's a static linking. But when come to .class file don't have any exe file. Sorry, .class file don't have any Windows library. It's not a prepared file. So .class file is not a prepared file here. See, .class file is not a prepared file. Yes, see, .class is not a prepared file. So .class file is not a prepared file. Okay, so .class file is not a prepared file. Then how it will run here? So this tested .class file has to link with Windows library. Suppose if it is placing on Windows OS, it has to link with Windows library. Okay, suppose 1 second. Suppose same thing. Yes, 1 second. Let us take one more ways. Suppose same thing. If it is on Linux OS, it has to link with the Linux library. 1 second. Yes. See, test.class file. Okay, Linux base. Placing a Linux base. Okay, test.class file, placing a Linux base. So when placing on Windows base, just link with Windows library. Okay, yes, test.class file when placing on Linux base, it has to link with Linux library. Linux base with Linux library, right? Okay, who will link it here? See, tested.class file is not a prepared file. It does not contain any Windows library. Okay, now this tested.class file moving on to particular ways here. Suppose moving on to Windows base. After moving on to Windows base here, this tested.class file has to link with Windows library. After linking, then communication starts. Who will link it here? Who will link it? Suppose if it is exe file, at the time of generating exe file itself, that Windows library linking. But in case of .class file, there is no link with Windows library. It's a purely Java program. Okay. Yes, to run the Java program, to run the .class file here, compulsory it has to link with Windows library. Not only Java program, even Python program, or C++, take any program. Any program, first of all, it has to link with Windows library to communicate with the hardware components. Okay. Yes, in case of Java, here .class file is not linked with any Windows library. It's not a prepared file. .class file is not a prepared file. So it does not have any Windows library. Then yes, this .class file has to link with Windows library. Suppose if .class file is running on Windows OS, this .class file has to link with Windows library. Suppose same .class file placed on Linux base. After it has to link with Linux library. Who will link it here? Jvm. There's Jvm. So between .class file, see between .class file and yes, between .class file. 1 second. Between .class file voice, .class file voice, this is Jvm here. This is Jvm here. Okay. Yes, now get JVM control picture here. Just 1 second. Let me take next page. Yes. So between dot class file and ways there is JVM layer. Now JVM layer complete picture here. This is JVM layer. So one more layer between this is JVM layer. So now JVM complete picture here. JVM here is a JVM here. JVM. So here is a JVM. 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 So JVM, right? Now JVM to Java virtual machine. Java virtual machine for Windows OS. Windows OS. Yes, has this way. Yes, JVM here, Windows JVM. That Windows, see, JVM is not a part of OS. Yes, I'll explain this. Wait. Now here, JVM. This is JVM between dot class file and Windows OS. This is JVM, right? Now the JVM has to link. So that JVM has to link. This JVM has to link dot class file. Yes, through the JVM linking to Windows library. Okay, so Windows JVM taking dot class file here and links to Windows library. Okay, similarly here, same here. Similarly, if it is Linux library, or if it is Linux base, on Linux base, Linux JVM. A Linux base of this is JVM here, Linux JVM. Okay, that Linux JVM has to link. If it is Linux base, then Linux JVM. Okay, if it is Linux base here, that Linux base on Linux base of this JVM here, Linux base, Linux JVM. So Linux library. Okay, see tested.class file. So tested.class file is not a prepared file. Tested.class file is not a prepared file. Yes, after moving on to base, tested.class file. After moving on to base, tested.class file. After moving on to Windows base, Windows JVM taking tested.class file links with Windows library. Once linked with Windows library here, then it communicates with the hardware components. After linking, then communicates with the hardware components. That's it here. Same dot class file moving on to Linux base. After moving on to Linux base here, Linux JVM. So this is Windows JVM. So this is Win JVM. So Win JVM, Windows JVM. Like this is Linux JVM. So Linux JVM. So Linux JVM taking tested dot class file. Linux JVM just taking your tested dot class file here. Tested dot class file links with Linux based library. So once linked here, then communicates with hardware components. That's it. This is what is happening in Java here. Okay. So JVM is responsible. Yes, to make the dot class file is independent platform. Okay. So JVM takes care of linking your dot class file to that current base. If current base is Windows base here, your dot class file links with Windows library. Who will link it here? JVM. Okay. Suppose if dot class file is running on Linux base here, now Linux JVM links our tested dot class file to Linux base library. Once linked here, then it executes generating output here. Similarly, Unix. If it is Unix base here, yes, if it is Unix base, that Unix, yes, if it is Unix base here, yes, 1 second. Yes, if it is Unix base, Unix JVM here, Unix JVM. Or Unix base, Unix JVM. This Unix JVM. Unix base, yes, Unix library, Unix base, Unix library. So Unix JVM, same tested.class file. Now same tested.class file, moving to Linux base, okay, or Unix base. After moving to base here, yes, that Unix JVM taking tested.class file, yes, then links to Unix library. Once linked, then communicates with the hardware components. That's it here. So JVM takes care of linking your dot class to current OS here. Okay. So Windows OS has its own JVM, Linux JVM, Unix JVM. From where this JVM here? JVM is not a part of OS. JVM is not a part of OS here. That should be installed separately here. JVM. Yes, JVM. So JVM stands for Java Virtual Machine. Okay. Yes. Java Virtual Machine. Yes, it is not a part of OS. Yes, it's not a part of OS. Okay. It should be installed. Installed on OS. Right? Okay. Yes. See, once JDK installed, then getting JVM automatically. It's a part of JDK. Yes, JVM is a Java Virtual Machine. JVM is a part of JDK. Okay. It's a part of JDK. It's a part of JDK. Okay, right? It's a part of JDK. So once JDK installed, yeah, JDK installed, JDK installed here, yes, automatically, yes, automatically here, automatically, yes, automatically here, automatically Jvm get installed, Jvm get installed, automatically Jvm get installed here. Okay, yes, automatically, yes, Jvm get installed. So Jvm get installed, automatically Jvm get installed here, right? Okay, Jvm is a part of JDK. Once JDK installed, one install here, automatically Jvm get installed here. Okay, Jvm get installed automatically here. Okay, so once JDK install here, yes, Jvm get installed automatically. Okay, right? See here. Next, one more thing here. Jvm is a exe file. See, your Java program is dot class file. Java program is a dot class file, but Jvm is a exe file. Okay, so Jvm is a exe file. Jvm is not a dot class file. It's a exe. Jvm, yes, see, Jvm developed in C++, C and C++. Jvm developed in C and C++. C++ compiler means you can write C program also. Okay, Jvm developed in C++. One second. In programming, yes, when you're running any program here, behind of JVM C++ program working. Yes, how C++ program working behind of JVM, I'll explain very clearly. I know that. Very clearly, I know that. So how JVM was developed? JVM internals, I know very clearly here. I'll explain JVM internals. Yes, if any Java program running here, so JVM is responsible to run the Java program. Right? So behind of JVM, some C++ program is working here. How that C++ program is running, how it's working, I'll explain clearly. Okay, I did lot of R&D on JVM. Okay, yes, before 2000 itself, starting at before going learning Java here, I did lot of R&D on JVM. Okay, what is happening behind of JVM, how C++ program is working behind of JVM, because that time I was expert in C and C++. Okay, C and C. First, my two projects are embedded C projects. Later switch to Java. So before switch to Java, I did lot of R&D and JVM here. That time I got some idea here. Okay, yes. So JVM, behind of JVM, how C++ program is working, we'll see. Yes, I'll explain later. In actual programming, I'll explain. Okay, yes. Here, JVM is a exe file. JVM is exe. It's not a dot class file. JVM is exe file and it's a OS dependent. Yes, and it is a yes, it's an OS dependent. It's an OS dependent. Here, Java program is a independent of OS. Java program is independent of OS, but JVM is a OS dependent. OS dependent. Okay, JVM is a OS dependent. Java program is independent of OS. Java program is independent of OS, but JVM is a OS dependent. Okay, see here. Suppose installing JDK. Yes, for Windows JDK is different, Linux JDK is different. To install JDK here, yes, suppose if it is on Windows OS, you have to download JDK for Windows OS. JDK for Windows OS. Okay, suppose Linux, if it is Linux OS, JDK for Linux OS. Unix OS, JDK for Unix OS. Next, Mac OS. For Mac OS, separate JDK. So JDK is different for different operations. Why? What's the reason here? JDK is a OS dependent. So JDK changing from OS to OS. So Windows JDK is different. Linux based JDK different here. Unix based JDK different. JDK changing from OS to OS. Reason, it can is JVM. JVM is a OS dependent. JVM is a OS dependent. Windows JVM, Linux JVM, Unix JVM. Okay. See, Windows JVM is having knowledge of Windows library. Linux JVM is having knowledge of Linux library. Unix JVM is having knowledge of Unix library, so that it can link with the library here. See here, yes, Windows JVM is having knowledge of Windows library, then it link with Windows library. Yes, Linux JVM is having knowledge of Linux library. Yes, it can link with that library here. So Unix JVM is having knowledge of Unix library. It can link with Unix library. That's it here. Okay. So JVM is a OS dependent. So JVM is having knowledge of OS library. Since having knowledge, it can communicate with that OS library here. That's it here. Okay. See, dot class Java program is independent of OS. Java program is independent of OS. but JVM is a OS dependent. JVM is exe file. Java program is a dot class file. JVM is exe file. Next, Java program is independent of platform, but JVM is OS dependent. JVM changing from OS to OS. That's it. Okay, right? Now here JVM is responsible to make this Java independent of platform. Simple answer. JVM is responsible to make Java independent of platform. Okay. Now here, see, finally here, question is here. Yes, what is our question? Yes. How is Java made us independent of platform? These are question. How is Java is an independent of platform here? This is question. Now, how to answer this one here? Simple. How to answer this? How is Java is independent of platform? To answer this question, first of all, explain about exe file. Just you have to explain about exe file. Okay. Next, explain about dot class file. Okay. So how Java is independent of platform? To explain this here, first of all, start with exe file. Okay. Yes, when you start with exe file, 100% they will believe your experience. Okay. Simply here, suppose when you started with exe file explanation here, simply automatically they will come to some conclusion. Oh, this guy is having some knowledge of exe file. Okay. Yes, even Jvm internals also you can explain very easily. We will come to some idea. Okay. So exe first you start with exe file. Okay. So exe file. What is exe file? Yes, start with exe. What is exe file? Exe file is a binary code file. Yes, it's a prepared file for specific operating system. Next, it's a OS dependent. So exe file linked with OS library. Since linked with OS library is OS dependent. After finishing that, come to dot class file. So what is dot class file? Dot class file is a purely Java program. Dot class file don't have any OS library. Okay. Now dot class file links to OS at runtime by the JVM. Okay. So dot exe file is a static linking. Dot class file is a dynamic linking. Dynamically linking to OS library here. Okay. So exe file is a prepared file for the specific operating system. Just you have to explain like this. Exe file is a prepared file for specific operating system. It's a OS dependent. Yes, when come to dot class file is not a prepared file. Dot class file is not a prepared file. Okay. Yes, dot class file after moving on to OS, then linking with the OS by the JVM. So dot class file after moving on to OS here, JVM links dot class file to OS library. Once linking here, then executes giving outputs. Okay. So exe file contains OS library. Dot class file does not have any OS library. Since dot class file don't have any OS library, it's independent of platform. Simple answer. Okay. So here, what's the reason dot class file is independent of platform? Simple answer. We don't have any OS library. Okay. So why exe file is OS dependent? It contains OS library. Simple answer. So why exe file? Why dot class file is not? Yes, OS dependent here. Okay. See, question is why exe file is OS dependent? It contains OS library. Yes. Why dot class file is independent of platform? Reason it does not. It don't have any OS library. Okay. Since exe file contains OS library, it's OS dependent. Yes. Since dot class file don't have OS library, it's independent of platform. Simple answer. This simple answer here. Okay. Simple answer. Okay. Here question is here. So how Java is independent of platform? Simple answer. If it is exe file, it contains OS library, OS dependent. Yes, now dot class file. Dot class file don't have any OS library. Since don't have any OS library, is a OS independent. OS independent of platform. Okay. Yes, JVM takes care of linking dot class files to OS library at runtime. Okay, at runtime. So it's a dynamically linking. Okay, so dynamically linking here. Okay, in Java, yes, in Java it's a dynamic link. In Java, it's a dynamic link. If it is exe file, static link. Static link with OS library. In Java, dynamic link with OS library. That's it here. Okay, simple answer. This is simple answer. So how Java is independent of platform? Yes, exe file is OS dependent. Reason it contains OS library. Dot class file is independent of platform. Reason it don't have any OS library. Okay, JVM takes care of linking dot class files to OS library. Okay, JVM is responsible to make this dot class files independent of platform. Simple answer like this. That's it here. Okay. Yes. If you explain more about exe, then well and good. Okay, these answer for this. So about independent platform. Okay, right? Yes. Next step. Yes, portability. Yes. Java application, portable application. So what is, first of all, what does it mean? What is portability? Okay. So what is portability here? What is portability? So what is portability? First question is what is portability? Because what is portability? Next, what is, yes, what is advantage of portability here? So what is advantage? What is advantage of portability? So what is portability? What is advantage of portability here? Okay, what is advantage of portability here? One second. Yes. So here portability. So what is portability? Yes, first question is what is portability? Second question, what is advantage of portability? Let us see this. So first, what is portability? Portability. Portability means, yes, easy to move from one location to another location. Another location. It's easy to move from one location to another location is a portability, is called as portability. Sorry, one second. Easy to move from one location to another location without any changes, as it is moving is a portability here. So easy to move from one location to another location, from one location to another location, from one location to another location without any changes, is a portability. For example, laptop is a portable, right? We can move it easy, right? But desktop is not a portable. Okay. Yes, desktop. If you want to move the desktop, you have to remove all the parts, keyboard, monitor, and CPU and everything you have to remove here. Then just carrying maybe in car. Yes, after going some location, you have to assemble again. That is not a portable. That's not a portable. Okay, right? Yes. Here, Java portability. So what is Java portability here? Java portability. So Java portability means Java portability. So what is Java portability here? Java portability. Okay. So what is Java portability? So Java portability means Java application build. Java application builds. Yes, can be moved from one OS to another OS without any changes, in the application build, Okay. Yes, without any application build here, without change in application build here. Okay. So Java portability means Java application build. Yes, Java application build can be moved from one OS to another OS without any changes, without any changes in the application build here. Okay. Reason. Yes, reason. What is the reason for this? Reason behind of this. Reason is Java program or Java program code is an independent of OS here. Java program code is an independent of OS. Independent of OS. Okay. Java program same for every OS here. Okay. Java program code is same. Okay. Java program code is same. Yes, same for all operating systems here. For all operating systems. Okay. So right one is this one here. So reason is here Java program code is same for all operating systems. All operating systems here. All operating systems. All operating systems. That's the reason here. Okay. Yes, even OS changing here need not change code as is you can move it here. Okay. So Java program code is same for all operating systems. That's the reason it's a portable OS. Okay. Sorry, it's a portable application. Java application, portable application. Reason, yes, its code is same for all applications. Okay. Now here, see. So what is advantage of, yes, it's here. Yes, Naresh, yeah. C program is a OS dependent. C program for Windows is different, Linux is different. C++ for Windows is different, Linux is different here. Okay, C and C++ OS dependent here. That code is, yes, OS dependent code. So Python code is same for all operations. Java code is same for all operations here. But certain language like C language and C++, .NET, these are OS specific here. Okay, .NET code is Windows based. Okay, .NET code we can't use on Linux based. Okay, because .NET compiler is Windows compiler, Windows based compiler. Okay, yes, C and C++ code. C program for Windows OS, C program for Windows OS. Okay, C program for Windows OS, C program for Windows OS. Next, Java program for Linux OS. Yes, different, not same here. Okay, next one more HTML. Let us take HTML. HTML is same for all browsers. HTML is code is same for all browsers. Okay, see HTML. See one second. HTML is a browser understandable language. Next, JavaScript is also browser understandable language here. HTML, JavaScript are browser understandable language here. Those are executing by the browser, not OS. JavaScript executing by the browser, not OS. Okay, browser is a OS dependent. For Windows OS, some browser browser is OS dependent. Okay, see JavaScript program, HTML program executing by the browser. Browser is OS dependent, but JavaScript, HTML, yes, is not browser dependent. It's a independent. Yes, same for all browsers here. So HTML, JavaScript is same for all browsers. Is HTML, JavaScript executing by the browser, not OS. Okay, suppose if it is dot class file, yes, even dot class files are executing by JVM, not OS. Suppose if it is exe file, directly executing by OS here. Okay, who will execute exe file? OS is responsible. Exe file executing by the OS. Dot class file executing by the JVM. Python program executing by the Python interpreter. Okay. Next, HTML code and JavaScript executing by the browsers, not OS here. Okay. That browser engine is a OS dependent. JVM is a OS dependent. Python interpreter is OS dependent. That's it here. I think you understand, right? Yes, Naresh, you understand? JavaScript is a browser. Yes, browser understandable language, not OS. JavaScript never executing by the OS here. Okay, browser text graph executing JavaScript. Okay, only exe file directly executing by the operating system. Yes, OS can execute only exe file. Okay, right? Yes, one second. See, now Windows OS is responsible to run Windows JVM, right? Yes, it's exe file. Windows JVM directly running on Windows OS because it's Windows exe file. Linux JVM directly running on Linux OS because exe file. Okay, next Unix JVM directly running on Unix OS because it's exe file. So this is Windows dependent exe file, Linux dependent exe file. If it is exe file, that will run on OS directly. Exe file running directly on OS here. Okay. Now dot class file is not exe file. So we will run not OS by the JVM. Dot class is running by the JVM. Dot class running by the JVM. Dot class running by the JVM here. Not OS. OS is not responsible to run the dot class files. Who is responsible? JVM is responsible here. Not JVM. Who will run the JVM? OS is responsible. Okay. Yes, JVM is running by the OS. Okay. Now dot class file is running by JVM. That's it here. Okay. If it is exe file, OS is responsible. Yes, come to HTML program. HTML program. Who will run here? Browser. Where is browser? On OS. Browser is on top of OS here. Browser here. This is a browser. Browser is on top of OS. Okay. Browser on top of OS here. Support test.html. Test.html. This test.html simply given to browser. Browser takes the test.html here. Okay. Yes, the browser communicates with Windows library, then output goes to hardware here. Okay. So browser is responsible to run the HTML file here. HTML with JavaScript here. The JavaScript is running with the browser, not with Windows OS. So browser, it will run the JavaScript and that output is sending to Windows OS. From that goes to hardware. So here browser is responsible. So HTML. So HTML running by the browser. Okay. Now this browser is exe file again here. It's a OS dependent. Yes, Windows browser is different, Linux browser is different here. See, for example, yes, take Internet Explorer. So Internet Explorer or Microsoft Edge. The Microsoft Edge, see this is Microsoft Edge here. Now this browser is a Windows dependent. Microsoft Edge you can't use on Linux base. It's a OS dependent. It's a OS dependent. So for example, take this yes, a Firefox browser or Google Chrome, these things here. Google Chrome or Firefox, these browsers are available for different operations. For Windows available, for Linux also available here. But this is not same browser. Suppose browser installing. When installing browser here, Windows browser is different, Linux browser is different. Browser changing from OS to OS, like a JVM. JVM changing from OS to OS. Browser also changing from OS to OS. Okay, right? Okay. Yes. Only exe file executed by the OS. OS can execute only exe, but not other files. Other files compulsory, some separate engine required. Except exe file, except exe, for all files separate engine required. Separate engine. For dot class file, JVM. For HTML program and JavaScript, this is a browser. Okay. For Python program, Python virtual machine. Like that, except exe, for all other programs, separate engines are required. That's it. I think you understand, right, everyone? Okay, how it's working. Okay, yes, fine. Yes. Now here, yes, portability. So what is advantage in portability here? Let us go to portability here. So what is portability? Advantage in portability here. Okay. So what is advantage of portability here? Yes. Now this question, how to answer this question here? Okay. What is advantage of portability? Application portability. Yes. Java program code is a yes. Java application is a portable. Java application portable. So what does it mean here? Java portable means Java application build. Java application build can be moved from one OS to another OS without any changes in the application build. It's nothing but Java portability. Okay. So nothing but Java portability. Simply here, yes, write, write, write once, write once and run anywhere. Run anywhere. Write once, run anywhere. This is slogan of Java. Write once, run anywhere. Write once, run anywhere. This is slogan of Java. Okay. So you get Java portable means Java application build can be moved from one OS to another OS without any changes. Without any changes in the application build. Write once, run anywhere. Okay. That is about portability, right? What is advantage in getting? What is the benefit of portability here? Why portable application required? What's the benefit in this here? Let us see the benefit here. For this purpose, I need to discuss about SDLC now. Okay, a software development lifecycle. Okay, so what is advantage of portability? For this purpose, I should explain about SDLC, software development lifecycle. Yes, in this step one, yes, collecting requirements from the collecting requirements from the client. So first of all, we should collect all requirements. Okay, collecting requirements from the client here, from the client. This is step one. Okay, yes, software development step by step. Step one, collecting requirement from the clients, yes, software, yes, requirement analysis, requirement analysis, yes, analysis, right? Requirement analysis, yes, requirement analysis here. So requirement analysis. Okay, yes, collecting requirement from the client. Who will collect that? The functional team. You see, when you're developing project here, there are different teams. Functional team, next development team, and testing team. There are three teams working on the project always. Okay, to coordinate all these teams, there's a project manager. On top of all the teams, there's a project manager. Project manager, he will coordinate these three teams plus client. Project manager has to coordinate all these like three teams: functional team, next development team, next testing team, and client also. Client side team. Okay. So functional team. What is a functional team here? Functional team, they will take all the requirements from the client here. Okay, they will take all the requirements. Okay. Yeah, they will analyze that requirements. Yes, who can work in functional team here? Who can work in functional team? The domain experts. Suppose your project is related to some medical information, related to medical transactions. That functional guy must have the medical knowledge, domain expert. Okay. Suppose your project is Java project is to maintain some warehouse, maintaining warehouse here. To maintain warehouse, that various knowledge, that functional team guys must have the various knowledge here, various transactions, raw material maintaining. Okay, that kind of things. Suppose here, yes, like purchase orders. Okay, yes, all that kind of information. They must have that knowledge. Domain expert. Domain experts are, yes, functional team members. Suppose developing the GST projects. GST projects. Yes, that guy, that functional team guys must have the GST knowledge, like chartered accountants. Okay, chartered accountants, they have the GST knowledge here. They will work on this here. So here, functional team, they will collect all the requirements from the client here. They will analyze this one here. After analysis here, after analysis here, after analysis, then next designing starts. Designing project here. Project designing. Yes, project designing here. So who will design the project? Yes, here, architect. That solution architect. So architect will design the project here. Architect with the help of functional team here. Functional team, yes, once again, collecting requirement from the client. Functional team will collect it. Fine. Requirement analysis. Who will this here? Functional team and architect. The architect everywhere he has to involve. Okay. Architect everywhere he has to involve here. Sometimes even architect should involve with, should interact with the client also. Okay, architect is the key role in the project. Architect is the key role. Okay, so at the time of collecting requirements, architect also has to go to client location. He has to collect all the requirements. Yes, architect plus that functional team with the domain experts. Okay, yes, requirement analysis. This also by the functional team plus architect. Next, project designing. Yes, mainly architect. Who will design the project here? Architect, not functional team. So functional team will update architect here. So as per that, with the help of functional team, architect will design the project here. Okay. So while designing project here, so many considerations. Considerations like there are different issues like client side issues. Okay. Development issues. Next, software issues. By considering many issues here, by considering many things here, that architect has to design the project. So while designing the project here, yes, he has to consider the client requirements. Okay. Next, and also he has to consider the development, yes, resources in that company here. Suppose in that company Java resource available, then how can he design project for other in other software? He can't, right? Okay. So he should, yes, he should think about client requirement plus, yes, the resource availability in the company here. Resource availability. So Java project, client requirement, maybe in Java it's easy, but don't have Java team. How can design? He can't design, right? So he has to recruit new team, right? So he has to consider client requirements plus the team availability. Yes, in our development company, resource availability. Okay. After that, next software. The software issues of Java. What are the features of Java? Java supports what? Okay. So here client requirement plus, yeah, the resource availability plus the software features. By considering all these three here, he has to design that here. So here architect is a key role. Yes, he has to decide which is the best software to fulfill client requirements. Okay, is it Java or is it .NET or is it yes Python or is it Hadoop or some Spark? Yes, architect has to decide. Architect is a key role in the project. Architect is good, project is success. Okay, architect is good, then project is well and good. Suppose architect, poor architecture, what happens here? Project fails. Not only, yes, in software field, even civil constructions also. Architecture is poor, the building will collapse within short time. Okay, so roads and everywhere, architecture is very, very important here. Architect is very, very important in every projects. Okay, half designing here, next developments. So next developments. Okay, developments. Yes, development. So development Java, development team. So Java, if it is Java, yes, Java team members. Development starts. Okay, after developing project here, next testing, right? Yes, testing. Next is testing here. After testing here, next what? Go live. go live. Next is go live. Means client is nothing. It's a production. Prod environment. Next prod. Prod is nothing with go live. It's live here. Okay, production. Move to production. Production, right? Yes. Correcting requirements. Next requirement analysis, designing, development, testing. Once testing is done here, yes, prod. Prod means production environment. Go live in the production means at client location. This is at client location. This is maybe in your company. This all is happening in your development company. Suppose if working for some TCS, all these things happen in TCS here. Suppose client is maybe somebody. Suppose client is, let us say, PayPal. Go live at PayPal company. That's it here. Okay. Yes, one more thing here. Between testing and prod, there's a pre-prod also will be there, but the rare case. Pre-prods. Before production, there's a pre-prod testing will be there here. Pre-prod testing. Pre-prod testing. Okay. This is rare case using. Okay. Yes, in our company, yes, in Hadoop projects, we did pre-prod testing here. Not all the projects here. Yes, in Hadoop project, we did pre-prod testing. See here, designing, developing Java code. Yes, at the time of developing Java code, we use the sample data. Using sample data, we develop the code, we'll test it here. If it is working fine, yes, moving to testing departments. Not testing team. Not testing team will test the application using sample data. It's a sample data, not real data. Okay. Next after that, yes, production. If it is production here, it's a real data. In production environment, it's a real data getting real data. So banking application, that banking data, real data, that customers data, banking customers data. Okay. Before going to prod, there's a pre-prod test. What is pre-prod testing here? Testing and pre-prod testing both are similar. The difference is here. Testing is a sample data, but pre-prod is real data. Okay. We'll take some real data from the client. From the client, we'll take real data. Okay. In real data, how that application is behaving, that also you have to test it. But this is a rare case because client real data is a confidential data, right? The data should not be given to anyone. But rare projects here. Okay. Yes, with the client permission, yes, taking real data and testing on real data. That is a pre-prod. Pre-prod. So pre-prod testing is nothing but testing with real data. Simple testing means this sample data. So development is sample data, testing is sample data. Pre-prod is a real data testing. Real data testing here. Next, go live. So these are things in this, right? Now here. Development, project develop, Java project developer Windows OS. Okay. Testing also maybe same Windows OS. Testing also same Windows OS. Okay. Pre-prod also Windows OS. Okay. Yes, go live. Client location also Windows. Everything is Windows. Well and good. No issues, nothing here. Okay. Suppose, for example, here client wanted to change ways. Client wanted to change ways. Okay. Yes, in case of Windows, we wanted to use Linux base. Why using Linux base? Reason, security reasons. Windows is not secure base. So Windows frequently hacking takes place. Hacking. Suppose the production on Windows base, there's chance of hacking the real data. Chance of hacking real data. Okay. So generally production environment, nobody will use Windows, maximum Linux base. Every data center, cloud environment data centers, they will be using Linux base because of security reasons here. Linux is secure base. With Linux base, there is no chance of virus and there is a chance of hacking data. Linux is secure base. Windows is not a secure base. So because of that reason, client wanted to change ways. Okay, change ways. Okay, right? Yes. Suppose now client wanted to use Linux base. For example, Linux base, maybe Linux base. Change ways. Okay, change ways to Linux base. Then what is the migration process? Yes, that's a migration, called as migration here. What's a migration process? Okay, yes, Windows to Linux base, Windows to Linux base. So what's a migration project here? What's the migration process here? Suppose if it is Java application builder. If it is Java application builds, Then what's a migration process here? Java application build. What's a migration process? For this purpose here. Yes. So Windows base already existing base. Okay. Yes. Windows base already using in live. Windows base already using in live here. Windows base and Windows base live Java application is running. Now that has to move to Linux base. How? For this purpose, first Linux server setup. Yes. At client location here Linux server setup. Linux server setup here. Yes, even I did that also here. Even I know how to set up the servers. Okay, Linux server. Yes, installing Linux base on some system. First of all, taking hardware, maybe high-end hardware. High-end hardware. Yes, in production environment, mostly using high-end hardware. Taking some high-end hardware. Next, installing Linux base. After installing Linux base, next we should update Linux base. After updating Linux base here, next step. Yes, we have to unblock some port numbers on Linux base. Suppose Java application running at some port numbers from 8080, that port number you have to unblock here. Certain port numbers you have to unblock. After unblocking port numbers here, that Linux system has to connect to the network. Okay, company network. That Linux system has to put into that company network. After placing in company network here means nothing but connecting with the cables and all this. After connecting, then IP address. We should configure the IP address. Okay, we should configure the IP address with company network IP address here. Okay, so once IP address configured here, then restarting Linux server here. Once restarted here, Linux system is ready on company network. Linux system is ready on company network. Once ready on the company network here, then yes, Java. Yeah, the Java application moving to Linux base. Linux base. How that moving here? How that moving here? So between Linux base and Windows base, yes, moving to Linux base. So between Windows to Linux base here, they see FTP, file transfer protocol, using FTP. So using FTP, we can move Linux base. Okay. Yes, we have to do some FTP setup. FTP setup on Linux server. After that here, using FTP, moving our application build into Linux base. After moving to Linux build here, Linux base here, live starts. Yes, totally how much time taken to perform to complete this operation, that migration process. So migration process, how much time taken here? If it is Java application build, how much time taken for the migration process? How much time taken for this migration process here? Yes, for this building Linux server, matter of 2 hours. 2 hours enough. Within 2 hours, we can build the Linux server. Next, Java application build from Windows to Linux server. Okay, using FTP, moving matter of 10 minutes. Within 10 minutes, that can copy to Linux base. After it come to live here. That means hardly 2 hours enough. Okay, Java application migration process hardly 2 hours. Even no expenditure. Without any expenditure, just only Linux admin enough. The one resource, only one resource, Linux admin is enough here. Linux admin, he will build the Linux server. After that, he will move the Java application to Linux build. Sorry, Linux server. After moving here, yes, then he will start. He will start the Java application. Okay, simply Tomcat server, just starting Tomcat server, the application starts automatically. Okay, so only one admin, no expenditure, nothing here. Okay, no expenditure, yes, no time care, without any time care. So within short time, with no time we can. So matter of 2 hours. Okay, matter of 2 hours for migration process. Suppose same thing if it is C application. C application. Yes, C application migration for C or C++. Okay, C language or C++ or VC++ or yes, .NET. .NET applications, application builds. Yes, before Java we have these kind of application builds. Before Java, in 90s we have C applications, because C++ applications, VC++ very famous in 90s. Before Java, VC++, it's a top position in the market for developing applications. Next, later .NET. Before .NET, already VC++ is there. VC++ from the Microsoft. Okay, so C language or C++, VC++, .NET applications. Then what's a migration process? Let us see migration process. So what is migration process on this here? Okay, so for these applications, migration process. What is migration process? Let's see that. Okay, so what is migration process? Migration process. migration process for below one. For below one. So what's a migration process? Okay. Now let us take same SDLC. Same SDLC I'm taking care. Yes, here are same SDLC. Okay. 1 second. Yes, 1 second. SDLC collecting requirement. Yes, already done over. Okay. Yes. Next, requirement analysis. Okay, 1 second. Collecting requirements, requirement on designing, developing. Suppose C or C++ application developed on Windows OS, testing on Windows OS. Yes, pre-prod on Windows OS, production on Windows OS. Fine. Okay. Now migration process. Migrating to Linux OS. Now migrating to Linux OS. Migrating Linux OS here. So what's the process here? So building Linux server, maybe 2 hours, that's okay, fine. Now C projects, C application builder. Yes, C app is a exe file. Is exe file, right? First of all, it's exe file. If it is exe file, who is dependent? Okay, yes, since it's exe file, yes, since it's exe file, yes, it cannot migrate to other ways. It cannot migrate to other ways. Okay, otherwise, so here only failing it. It's a exe file. Since it's exe file, cannot migrate to other ways. It cannot migrate to other ways. Okay, then what's a migration process? Yes, rebuilding application. Yes, to migrate into other ways here. To migrate to other ways, it has to rebuild it. To migrate to other ways, yes, that it has to rebuild here. It has to rebuild here. It has to rebuild here. It has to rebuild. It has to rebuild. It has to rebuild. Okay. Yes. 1 second. 1 second. 1 second. Yes. Okay. To migrate to other ways, yes, it has to rebuild. Okay. Suppose C program developed on Windows OS. Same program placed on Windows OS, it has to rebuild. It has to regenerate exe file on Windows OS. Suppose C program tried to compile on Windows OS. Same C program tried to compile Linux OS, sorry, Windows OS, lot of errors. Lot of same C program. Okay. Sorry, C application is exe file. Since its exe file cannot migrate other ways, it has to rebuild. Suppose C application or Windows OS. Same that code try to rebuild on Linux base. Rebuilding means first you have to recompile it. After recompilation, if no errors, next you have to generate exe file. Now recompilation, same code recompilation as it is on Linux base, it fails. Thousands of errors getting. Yes, same program, same C program, try to compile on Linux base, lot of errors, thousands of errors getting here. Reason, C code is a OS dependent. Okay. Yes, C program. Yes, C program. Yes, C program code. C program code is an OS dependent. Is an OS dependent here. Okay, is an OS dependent. So OS to OS that code changes here. C program code is OS dependent. Even C program for Unix is different. C program for Linux also different here. Even Unix to Linux also chance of changing code here. Okay, C program code is OS dependent. Same C program cannot work on different operating systems. Okay. Then what is next step? Yes, getting lot of errors. So why C program code is OS dependent here? Then we should change the code here. That means redevelop. Yes, redevelop. Nothing but just is redevelopment. Yes, redevelopment required here. Yes, we should redevelop the same code here. Same code you have to redevelop here. Redevelopment required here. Redevelopment. Okay, redevelopment required here. So we should take the code here. Where are errors getting? That code you have to replace. Okay. Yes, code modification. Redevelopment means code modification required. Code modification required. Code modification required. Code modification required as per Linux base. As per Linux base, we should change the codes. Okay, see, after changing code here, next you have to generate exe file. Okay, after finishing code modification, you have to generate exe file. See, once the code is modified, it should undergo testing also. The testing should be repeated. Okay, so what is happening here? See, yes, in this life cycle, 3 steps not necessary. Okay, no redevelopment. This step we has repeat, testing also repeat, report. These all steps have to repeat. Yes, repetition of this. So what happens here? Yes, time taken this is. Time taken. Suppose this project is taken for almost for 1 year. 1 year. Yes, out of this total SDLC here, this phase, development phase, testing phase, almost 80% of time required for the development, testing, pre-prod and prod. This phase will take 80% of total project time here. So for this purpose, 20% of time is enough here. So this phase will take 80% of project time. 80% is. That means that 80% of project time repeating again. 80% of efforts are repeating again, right? Suppose this project was taken for 1 year. 1 year. So 80% of 1 year means 9 months, around 9 months. So this yes, migration process, how much here? 9 months taking here. Yes, that 9 months. So this 80% of that total time repeating. So almost 9 months. It will take 9 months to migrate into that. Okay, so client has to wait for 9 months, right? Client has to wait for migration process. It's not easy. It will take for 9 months. Client has to wait for 9 months. Suppose client is waiting for 9 months. What happens here? Loss of his actual business, right? Yes, maybe loss of his actual business. Okay, this project is secondary. Wait for the purpose of this project is loss of his own business, right? That actual business loss, right? So 9 months waiting. So actual business loss. So that waiting period 9 months. Not only waiting here, resources required. Yes, second development resource required here. Testing resources, all the resources is a costly. Okay, so migration process is costly and time taken. Same thing if it is Java. Yes, migration process with no cost within a short time it can be migrated. See that the difference. There's a benefit of yes application portable Java here, right? Same point exactly presented by the Sunsoft at the time of releasing Java in the year 1995. Okay, same with that slogan they came to the market here. Okay, Java application, a portable application, easy to migrate from one ways to another ways. With same that features came to the market. Okay, yes, that time here, yes, at the time of releasing Java, yes, I was in engineering. Okay, they have released with these features here. Migration path very simple. Yes, application port same thing, right? So with that feature they came to market. So with that features, many clients attracted to Java. Okay, they tried thinking about Java here. So many clients, yes, already that time already projects in VC++. Okay, by the time of releasing Java, already many projects are developed in VC++, C++, and C language also. Okay, don't have .NET that time. 95 don't have .NET here. So many of the clients they are started thinking about Java. Okay, yes, next Java many features added. So many clients have started working Java. Okay, many clients have started using Java here. Okay, yes, by the year 2004, yes, JDK 1.5 released with many features. With that features, your application Java got the success. So many clients started migrating to Java. Okay, that old previous applications before 2005, the previous applications were developed in VC++, .NET, SAP ERP, and Oracle ERP. So before that, okay, by the year 2010, by the year 2010, most of the projects were converted to Java because of its features here. Most of the projects like VC++ projects, .NET projects, SAP projects, Oracle ERP, most of the projects were converted into Java here because of its features. Okay, next one more thing here. Yes, one of our client is using SAP. SAP is a costly. Yes, almost is paying every year 2 crores of amount here. Yes, SAP that licensing. Okay, but the client is not in a position to bear that 2 crores of amount here. Okay, so further that client approached us. Okay, through somebody here, approached us. They asked to convert into Java. Yes, we did that. One of our project is SAP project conversion Java here. That SAP project completes same ERP. With all that ERP features, we had our separate application in Java here. Now client is very happy. Java, it's a freeware, free of cost. The client using free of cost here. It's a freeware. Is very happy. So almost 2 crores of amount every year. Yes, is saving here. Okay. So with that 2 crores of amount here, yes, he is able to run his complete business. Complete expenditure is going with 2 crores of amount here. Okay. So the one more features of Java here. Yes, Java is a freeware. Freeware, yes, is not a costly, easy to use, right? Okay. So because of that reason that SAP here, even SAP projects also convert into Java. Oracle ERP also convert into Java. Most of the projects in market here. So by the year 2010 here, most of the projects in markets convert into Java. Now currently, what's a current scenario in the market here? 90% of the applications Java applications. You take any application like Flipkart application, yes, Amazon online services, or Facebook or Google. You take what are project here. 90% of projects, 90% of projects are yes developed in Java. Okay, 10% like ERP projects are there in markets. 10% ERP projects are there. Okay, most of the projects, even big data projects are not Java, right? That big data applications Java using Java, like Core Java, yes, even Spark using Java. Spark also using Java here. So most of the applications are developed in Java here. That's the reason Java has a lot of demand here. Java resources has a lot of demand in the market. Reason is this here. See, 90% of applications, lakhs of applications running in the world, right? Lakhs of applications. Who will maintain that? Lakhs of applications developed in Java. Okay, who will maintain that? Okay, who will be the support? Java resources. That's the reason Java has lot of demand. Java resources, lot of demand. Reason many applications, 90% of applications require support. That support, right? Who can give the support? Java resources. That's the reason Java field has become evergreen. It's evergreen field here. So never ending here because 90% of applications running Java coding, right? Java. Yes, that suppose any issue raises, that support required here. Who can give support? Java resources. That is in the market, many Java resources requirement always here. Okay. Yes, suppose new project secondary. Suppose new project may not be developing that. Just you think it here. Suppose new projects are not developing in Java. No problem, no issue. Already 90% of projects were in Java only here. To support 90% of projects here, who require here? Java resources. That's the reason Java has become evergreen. Okay, even new projects are not developing Java. Even new projects are developing Java. Yes, recently we got one project. Okay, we have only 9 months to finish that project here. Okay, some requirement is going now. Currently, we are taking some 3 to 4 years of experience, guys, and 6 to 7 years experience. Okay, this kind of guys we are taking. Even freshers also. Yes, we are taking. Yes, 10 resources, freshers. Okay, 10 resources we are taking. Yes, fresher resource in our project here. Okay, like is continuously getting here. Projects, Java projects, never ending basis. Okay, yes, everywhere Java resource required nowadays here. Okay, yes. So that is advantage of portability here. Portability, application and portability advantage here. Okay, Java application easy to migrate from one OS to OS, another OS without any risk. Risk is no risk here. Risk factor less. No risk. No risk. And next, no expenditure. That is one more features of Java here, right? Okay, application and portability. Next, Java is an OOPS language. Object-oriented programming language means Java supports all the features of OOPS concepts. Sorry, not all. Java supports main features of OOPS concept. Since supporting main features of OOPS concept, it's a OOPS language. Okay, yeah, that features we'll discuss next. Next, scalability. See, any software saying that scalability. Any software. One second. Yes. See, in market, any software, any new software release, simply they will say that scalability. Okay. What does it mean? See, Java is a scalable Python is scalable, Hadoop is scalable. Suppose testing Selenium tool release. There is also in the scalable here. So click the tool, tab the tool like this. Any tool release in the market here, any language release in the market, simply first to one is scalability. Everyone says that scalability. So what does it mean here? Scalability means what? Yes, anyone can answer this. What is scalability? What does it mean? So what is scalability? See, for every software, scalability is a common feature. What is scalability? Scalability means, yes, scalability means increasing, okay, increasing one section, increasing or decreasing, okay, increasing or decreasing functionality, increasing or decreasing scalable, simple meaning here, increasing or decreasing functionality without affecting existing functionality. So increasing or decreasing functionality without affecting existing functionality is a scalability. Scalability means increasing or decreasing functionality without affecting existing functionality. This is scalability. Okay. Now Java is scalable. What does it mean here? See, in software, first high level language is C language. C is the first high level language. Okay. In C language, data types. Okay, data types. Okay, right? Yes, next step. Yes, operators. There are some operators. Okay, operators. Next, control statements. Yes, operators like mathematical, relational, logical. So the list of operators. Next, control statements. Okay. Next, some programming syntax here. Okay, maybe some arrays concept here. Arrays. Okay. Next, yes, arrays concept here. Arrays, some strings concepts like this. Strings. Okay. These are in C language, they're minimum features, right? In C language here, data types, operators, control statements, syntax, programming syntax here, arrays, strings. Okay, next, methods, writing functions. Okay, these things in C language, these things are there, right? Yes, come to Java. These all these things following here. Yes, Java following all the C language rules and added some new features. Even C++ also, by following all the features, added some new features. Next, Python also, by following all this, added some new features. Scala also, by following all this, added some more here. That means without affecting that existing functionality. So without affecting that existing C programming codes. Okay. Yes, new softwares are developed here. Okay. So new software, what are the new softwares are releasing in the market here? Almost every software following these features, apart from its own features. Okay. So this is basic system. This is basic code, that coding concepts here. Okay. So every language, every tool compulsory has to follow these concepts. Otherwise, nobody will use their software here. This sure. We take any software here, every software has to follow these fundamental rules, that C language concepts. Otherwise, no one can use that software. This is nothing but scalability concept here. Java is scalable. That means Java following existing rules of software without violating the rules of the software with C language rules here. Yes, Java has its own features. So Java is scalable. Next, Python is also scalable. So Python, without violating that C language concept here, new features added in Python here. Even Scala programming also, without violating that C programming rules, yes, it's one features. Suppose Selenium tool. In Selenium tool also same rules. Okay, click view, tab view, take any water tools or maybe language. Everyone has to follow this kind of thing. That means scalability. So scalability, increasing or decreasing functional, that means adding or removing functionality. Okay, without changing that existing C language concepts here. It's nothing but scalable. Java is a scalable language. Okay, right? Yes. Next one, Java application secure. Okay, Java application secure. Suppose any website developed in Java, yes, that site is trustable. Suppose visited some Java application, that application visited some sites, that site developed in Java. Okay, if from that site downloading some programs, maybe your login form downloading, login from a form collect your only your data. Suppose if website developed in other applications, not only login form downloading here, along with login form, it will download other programs also. That other programs will go to your local system and reading your local resources, means your personal data. Okay, not only login form here, that form behind the program, that form here, some programs taking your data without your knowledge, means data hacking. Data hacking takes place. Suppose same thing if it is Java application, that login form developed in Java applications here, then JVM will not allow to access your local resources. Okay, suppose when visiting any website which is developed in Java here, that website applications will not, that means in behind of that application is JVM, that JVM will not allow to access local resources. So it's a secure. Java applications is secure. Okay, right? Yes, if any website developed in Java application is trustable site. Suppose other than Java may not be trustable. Any website developed in Java is a trustable. Okay. Yes, if that website is trustable, yes, client frequently visiting the rest. If not trustable, first time, yes, maybe visiting. Next time you won't visit. If not trustable, you won't visit here. Loss of customers. Yes, if site is trustable, yes, many clients visiting that site. So getting lot of business. There's nothing but security concept here. So these are the features. They are the primary features of Java. These are the primary features. Yes, these are primary features. Where is that here? They are primary features. Remove that. Okay, no problem, no issue. Yes, so that's all about features of Java. Yes, see this. Same thing is there in document here. Just you can follow document here. That's document. Yes, document I'll share you. Yes, today I will talk to online team here. So as per online team, I'll share this document here. Okay, online team has to provide the information. Okay, as per that online team, today I'll share these documents. Till now, whatever discussed here, it's there everything the document here. Everything is there in document here. Okay, yes. So up to this, the Java overview, Java features, and all that overview completed. Next, Java installation. Okay, next Eclipse installation, Java setup, and next programming, Java programming. So next class will start. So next class, how to install Java, how to set up Eclipse, and all these things we'll discuss in next class. Okay, yes. Next class will be on Monday. Tomorrow don't have the class. This Saturday not taking class, but next Saturday I will take the class. Okay. So because generally first week Saturday not taking classes for every batch. Reason Monday maybe somebody may be joining. So for that reason Saturday, first week Saturday not taking care. Second week Saturday I'll take definitely. Second week, third week, all the till end of the course, Monday to Saturday class. Only this Saturday not taking class. Okay, right? Yeah. So next class will be on Monday. Yes. 1 second. Yes, URL changing. Yes. For next class, URL changing here. So not this URL. Yes, you should get the new URL. 1 second. 1 second. Yes. So next class, it's a new URL. That your class, your link, that link will be changing here, not same link here. Okay. See here, to get this new URL, yes, this is my WhatsApp number. Just you ping me my WhatsApp number. I think already given many times here. So 8178189123. This is my WhatsApp number. Please ping me. I can share that URL, that new URL here. 8179189123. This is my WhatsApp number. Just ping me your details. I will have to already group created. It's going on group created here. Okay, I think 6 to 7 members are there in group. Already group created. Okay, Yes, just WhatsApp me your details here. I will add to group. Okay, that link will be shared in the group here. Okay. Yes, WhatsApp is the best way for communication between us. Right, okay. Just ping your details. I'll add to that group here. That URL I'll share on Sunday. So Monday class URL I'll share on Sunday. Sunday evening. By the Sunday evening, I'll share that URL. Right, okay. Yeah. Any doubts? Yes. Any doubts? Yes, guys. Any doubts? If no doubts, let us wind up session. Next class, Monday, same time, 9:30. Right? Thank you. Yes, see you on Monday.